In the next few slides, I'll talk a little bit about Ultrasonix transducers. Note that Ultrasonix does not manufacture its own transducers and that we purchase our transducers from third-party OEMs. Therefore, some of the information related to our probes are proprietary to our OEM suppliers. Ultrasonix uses the naming convention shown in this slide for its transducers. The presence of an M in the beginning signifies a mini probe. If the probe is a motorized 3D probe, a 4D appears after that. The type of the probe is next, which is used for specific probes such as the phased array and biplane probes. The following letter is for the geometry, which is either L for linear or C for curved. The two numbers which follow are the maximum and minimum cutoff frequencies of the probe and show its bandwidth. The number after the slash is the size of the probe face in millimeters for linear probes or the radius for the curved probes. The specification of all of our probes can be found in the probes.xml file. This file contains all the geometric dimensions of the probes as well as other information such as its vendors. The geometric information are essential for proper time delay calculation for automatic focusing of the beam in the transmit and receive. It is also important for proper scan conversion of the images for display. The probes.xml file can be found in the exam installation under ultrasonix/exam/config folder and in the SDK under SDK/texo/dat folder. Here is a snapshot of the contents of the probes.xml file for a typical probe. As can be seen, the ID of this probe is 2 and its name is L14-5/38. From the probe naming convention, we know that this is a linear transducer with a bandwidth from 5 MHz to 14 MHz and its face is 38 mm long. It has been released for all 3 revisions of the main module. The vendor is Prosonic, but there are 2 part numbers, one with the GPS and one without it. The specifications for the biopsy needle guide follows. The center frequency is reported as 9.5 MHz and the bandwidth as 9 MHz, which is consistent with our understanding that the bandwidth is from 5 MHz to 14 MHz from the probe's name. We can also see that the transducer has 128 elements which are located at a pitch of 300 microns. We have carried out some tests to determine the bandwidth of our systems on the receive side, and I'm going to present a few slides on that. We have tested the Sonix RP with 32 receive channels against the Sonix Touch, which has 64 receive channels. We have also tested how changing the cutoff frequency of the AFE5808 would affect the bandwidth of the Sonix Touch system. The details of these tests can be found on our Wikisonix. This graph shows the comparison between the RP and Touch. As can be seen, the Touch has a significantly higher bandwidth. This graph shows how increasing the cutoff frequency of the AFE5808 affects the bandwidth of the Touch system. Thanks for bearing with me through this presentation. I hope you have enjoyed it and have a better understanding of how ultrasonics systems work now.